Alright, so on the last video lesson we were talking about graphing logs. But we're going to go into more detail about graphing. And I don't know why it's purple, but oh well. We're going to graph f of x equals log base 2 of x. Okay? First things first, if you don't know what you're doing, always create a table of values. If you don't know the numbers, make numbers. So we need to generate a table of values to graph it. So obviously I know I'm going to have a vertical asymptote at x equals 0. I know that for a fact. I also know that the domain is from 0 to infinity. And I know the range is all real numbers. Now we're going to see here why in a minute. Okay, so I'm going to say I want x to be let's deal with 1/2. Let's deal with negative 1/2. Or no, we're not going to do that. I want to do something here. We're going to do -1. We'll do -1 and see what happens. Then we'll do 0, and then we'll do 1, and then we'll do 2, and then we'll do 4. Okay? What power of 2? So log base 2 of -1, what power of 2 gives you -1? Well, I'm going to tell you it doesn't work. It is a complex number that is an element in the format of a plus bi. It is a complex number. It's not a real number. It's not going to work. However, if I do log base 2 of 0, in other words, what power of 2 gives you 0, you're still going to have the same thing. Error. There is no power of 2 that gives you 0. I don't care what it is. No power of 2 gives you 0. It doesn't work. There is no real number that will give you 0. There is a complex number, but we cannot deal with complex numbers, so it's error. Now, what power of 2 gives you 1? And it's not a trick question. Anything to the what power equals 1. If you said 0, it's right. Anything to the 0 power is 1. So it works. So log base 2 of 1 is 0. Let's do log base 2 of 2. What power of 2 gives you itself? 1. Yes, that's good. And if you do log base 2 of 4, what power of 2 gives 4? Well, 2 squared gives you 4. So immediately you can draw a graph, label your x and f of x axis, so label your independent axis, your dependent axis. And let's go ahead and draw a vertical asymptote at x equals 0. Okay, so x equals 0, meaning, your domain cannot include 0. You cannot be to the left of 0. Okay, so let's look at it. Well, I know that, and I'm going to use, let's go with pink. All right, at x equals 1, I'm going to have, and then at x equals 2, and then 3, and then 4, right? Well, essentially, when x equals 1, I get 0. So I'm going to get this point right here at 1, 0. When x equals 2, I get 1. So let's go ahead and make this 1, and let's make this 2. So when x equals 2, I get 1. When x equals 4, I'm going to get 2. And so the function, the pink function, is going to approach negative infinity as x gets closer and closer to 0. So as I approach from the right-hand side, from the positive direction, going towards 0, I'm going to get closer and closer down here to negative infinity. But I will never exist over on this side. And a really cool factor is all of this space over here to the left of the vertical asymptote is actually ingeniously part of the complex plane. So they are complex numbers. You cannot graph them. They're going to be complex numbers. They don't exist. Okay? And the reason why is because all complex numbers are going to exist. And as far as a phase variant, later on you learn about it in complex analysis. You have a separation between the complex number plane and the real number plane, which are two sets of universes that exist within the universal number system. What that means is that there is a complex expansion of any logarithmic form. But luckily you guys don't have to learn that. So I'm just going to mention that in passing, and if you want to pursue that, you can. It's very fascinating. Think of shadows. Think of projections. That's what complex numbers do. If you remember the first part of the class, I was talking about how you have an x squared, you have a parabola. If the parabola was vertically translated and if it does not cross the x-axis, then the parabola obviously has at most 2 imaginary roots, and these imaginary roots get graphed onto the complex plane. And a lot of the graphs, the complex plane, graphs of the complex plane, maintain a lot of the aspects of the real number plane, because it's all cardinal and it's all ordinal, and it is a vector space, just as our real numbered space is a vector space. So it is kind of fascinating if you want to think about stereographic projection. But this is graphing log base 2 of x. What I will be required you to talk about is, hey, you will have to tell me that, the domain, you will have to tell me the range, you will have to identify where vertical asymptotes exist, and you will have to be able to create a list of values and graph. And that is all I will be asking you to do. And this is just if your base, that's right, that's just if your base is 2. You have to deal with 2, 10, and E. So I hope this makes sense. If you have any questions, please feel free to email me. I'm going to do 2 more lecture videos when the base is 10 and E.